Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 98th question of the problem solving series and the 8th question of the topic tree. The difficulty level for this question is medium and this question was asked in PayTM, OlaCabs, Walmart and few more companies. Top view of a binary tree. Okay. So in the previous question we have solved the right view of binary tree. So one looking from the standing in the right and looking this tree from that side. But here it's top view. Someone sitting at the top and looking at the tree. So what would be the view, like what he can see? Okay, so if he looks it from the top, he'll be able to see, his vision will be like this, right? So he'll be able to see 4 for sure, right? Because nothing is obstructing 4. So he'll be able to see 4. He'll be able to see 2. Will he be able to see 5? Because 1 will come in place of 5, right? So he won't be able to see 5. He'll be able to see 1, like from the top. And similarly, the 6 will also be hidden from 1. He won't be able to see 6. Okay. How I will say, like we'll discuss that. Yeah, if 5 is also not seen, 6 is also not seen. How you can say that it can't be seen, but it can't be seen because we have the label. Okay. So this is 0, and we are going this side. We are going this side, so there is symmetry. So with that symmetry, we can't see 5 because 1 will cover it. Because once we have gone left and then we have gone right. So we are at the same position and this is covered by 1. Same goes for here. So this 5, 6 will be very close and this 1 will cover both of them. So we won't be able to see 6. Will we be able to see 3? Yes, nothing is obstructing, right? So 3, anything at the top is coming. So we'll be able to see, nothing is here, right? So 3 will be able to see. Will be able to see 7? Yes, nothing is here, right? So we'll be able to see 7. So this would be our top view of the binary tree. For this tree, this would be the top view. If we see this example, what would be the top view? Starting from the leftmost, you can see this 2. You can see 1, but then you can't see 4. Can you see 3? Of course you can see 3, but you can't see 5. 3 would obstruct 5. And you can see 6, nothing is there. So this would be the 2, 1, 3, 6 would be the top view for this binary tree. Now how do we solve this? So we have solved, we know how to do a level order traversal, right? So we know that this is a 0th level, this is a first level, second level, okay. Now when we are traversing, we are going to the left or we are going to the right, okay. Now when we are going to the left, so we are changing the direction towards the left side. So if this is 0, we can say that okay, we have moved -1 this side. Now when we go here, we can say okay, we have moved +1 this side. So that we would understand, okay, so if this was 0, the 0 already exists. That has come here. So this is also at the 0th position. So 1 will cover 5. Same goes for here. If we add +1 to the right, so right is +1, like an integer line, right? Number line. We are studying class 5 or 6. So +1 is here. We are going to the right side, but again we are coming to the left side 1 unit. So 1 minus 1 into 0. So this is at 1, but this is at 0 again. So 1 will obstruct 6, and this is +1. We are going to the right side. So 1 plus 1 again 2. So this would be 2. So we will be able to see those things which have come for the first time, right? If we are looking at the top, we will start from the top. So to check whether this position we already have or not, we have already covered or not, we'll use map, okay? And for the traversal, like we can use a level order traversal for this to find out, okay, we have traversed all the trees. We'll see at which position are there. If it is already in the map, then we will not add it to our vector. Okay, otherwise we'll add it to our vector. So let's code it and then we'll try run our code for this example. Okay, so what do we need? We need an answer vector. Vector int, say result, res. Okay, so if root is equal to null, just return an empty vector, return res. Okay, base case covered. Now what we'll do, we'll take a map which will have our position and the root node, root's value, okay. Map int and p. Okay, let's int this and p. Now we take a queue, okay, and in the queue we will take the tree node, okay, and then here we will take the position. You'll understand what we have done here. Wait for some time. So we have taken a queue as well, right? Now what we will do, we will insert. Let's insert the q dot push, the root, make pair. Let's make pair and we will insert root comma 0, okay, inside the queue. So we have inserted this. Fine. Now we will run this while queue is not empty, okay. While not queue dot empty, we will run this loop and we will traverse the tree and we will add the view to those nodes to the vector, those nodes value to the vector, which can be seen from the top view. Okay, we'll use this map logic, you'll understand. So now we have inserted this root 1. Okay, so this root value, okay, this is not, so we have inserted root only, okay, this whole root node and the label of it. Label is 0, not label, okay, the position of it, okay, index line position of it, right? If this is the index line, this is 0, this is -1, this is -2, this is 1, this is 2, like this, the vertical position you can say, okay. Yeah, so this is done while not q dot empty. Now let's have what we'll do, we'll have tree node, strict node, and we will, with this q will q dot front, okay, q dot front will have this, okay, not tree node, we will get the whole thing, okay. So let's take pair of node strict int node, okay, q dot front. We have this node here now, okay, which has both the root and the 0 here, okay. Now we'll pop the element because we have visited this. Now we'll go to the queue, so we don't need this, so we'll pop out and we have the node here, okay, at this thing. Now if this mp dot find, if we see that the node dot first, which is the root, okay, node dot first, this value, okay, if this value is not present in the map, okay, that means if this value is not present in the map, then we will push this value mp node dot first value, not node dot first value, we'll insert the position as the like index in the map and the value as the node dot first value. So mp node dot second, which is 0, would be equal to mp this node dot first value, okay. So we have inserted in the map 0 position, we have inserted this one value, okay. This is done. So if it is, since it is, we don't have anything, 0 is not there in the map, so we have inserted this. Now what we'll do, we will see if this node dot first left, okay, this node dot first is this node, this part root, so roots left, if we see that if it is not equal to null, okay, then what we will do, we will insert it into q dot push node dot first left, this left node will insert, and then whatever the value is there, node dot second, the integer this value -1, since we are going to the left side, so we'll give node dot second -1, that means 0 -1 -1. Okay, if node dot first right not equal to null, okay, then q dot push node dot first right node dot second +1. Okay, so we'll add this node dot second +1 inside the queue, and then yeah, we will close it and we will return result. Oh, not return result, okay, we don't have anything inside the result now. So this is done, right? So now we have everything in the map. So what will happen here? Okay, so here empty 0 1 would come. Now when it will go here, so empty -1 in -1 2 would come. Okay, then and in empty 1 3 would come, right? Now it would go here for this -1 -2, empty -2 4 would come. Now its value would be minus, so here when here it's -2 from -1 -1, but here since it's right child, -1 + 1 0, so before entering MP 0 equal to 5, we will see, okay, already MP 0, if MP dot find node dot first value equal to, okay, this won't be node dot first value, this should be node dot second, sorry, because we are checking the position, right? So node dot second already M0 is there. Node dot second, this time we got this as 0, right, when we push. So 0 already exists, so we can't make that MP0 equal to 5, right, because this has covered it. Same will happen for this, and we'll have everything in the map. Now what we'll do, we will just traverse the map for auto it equal to mp dot begin, it not equal to mp dot end, it plus plus. Okay, here what we'll do, result dot push back, what will push, we will push the value, right? So it this it second, okay, it second we will push into the result. Okay, so this, it would be start, since it's a ordered map, so it would start from the left part and we'll get all the values from like this 4 to 137, and then we can return result. Okay, so for this example, this, it would be 0 -1 plus 1 -1 plus 1, so it would become 0, 0 plus 1, we are going to the right, it would become 1, and 1 plus 1, it would become 2. So MP0, we will see nothing is there, so 1 will be 1 will get inserted. My MP -1, nothing is there, 2 would be inserted. MP0 already the element is there, so we won't insert this into the map. Then MP1 before, so MP1, this one before this, once done this, so we are going at the label order, right? So once we have done this, we won't go here, we'll go here. So +1, already MP +1 3 is inserted, so MP +1 here, this was 0, right? So this would be 1, right? So MP1 already 3 exists, so we won't insert it into the map, can't insert, and we'll be able to insert MP2 equal to 6 to the map, and then we'll traverse the map, and then we'll get this answer. Okay, I hope this solution is clear. Now to extend this, the question could be, find the bottom view of the binary tree, right? So here in this case, Like we discussed the left view of the binary tree also while discussing right view of the binary tree. Here, while discussing top view, the question could be find the bottom view of the binary tree. That means instead of looking it from here, we are looking from the down, right? So if we look from the down, then we will be, our map would be actually replacing the value, right? So we won't have this condition. So let it overwrite, okay? Because we are seeing from this. So if we traverse from the top, we are not traversing from the bottom, right? We have the root. So when we get this, like this 0 is there, MP1 is already there, but this 5. So when we get this MP0, already it exists, we will not check this condition and we will directly insert this. So that this MP0 will be equal to 1 will be replaced by MP0 equal to 5. Because we don't have any problem, we are looking from the bottom. So whatever comes at the last in the tree, that would come. So the key code would be same, just this condition we will remove, okay? And MP node dot second will be equal to MP node dot first value every time. So this would be replaced and we will get the bottom view with the same code. Okay, I hope the question is clear. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 98th question of the problem solving series in the Geeks for Geeks platform. Top view of binary tree. You can see the difficulty level is medium, and these are the 3 companies. We can see the tags that have asked this question. We have already discussed the same examples, right? So we will just look at the code and see this is same as what we have discussed already. We take this queue pair and then this insert this and same, right? I don't need to discuss this again. You can see we get the node, we check if it is node dot second is the first thing to be entered in the map, it doesn't exist, then we insert this node dot first data. So here in this case we have the type is node and the value, instead of value we have data. So that change you have to make, and yeah, you can try this. So the link to the question is in the description, so you can check the code and match it. And yeah, it's same as we have discussed. We traverse this map and insert the it.second into the map in the result vector, and then we return the result. So we'll directly submit this code. See, all the test cases have passed. So, and similarly you can try the bottom view of binary tree. Okay, so that is also simple. Okay, I have removed that code. You can just search bottom view of binary tree and the code would be same. Okay, same thing we have done, just we have removed the condition, and that would override this since we are looking at from the bottom, and the code is same. So we'll just submit this as well. Okay, so we have solved 2 questions in this video actually. Okay, yeah, see you also in the next video where I'll be explaining the 99th question of the problem solving series and the 9th question of the topic tree. Jai Jai Indra.